Hi everyone, my name is Gerald. I am here to teach the PIC microcontroller through assembly level language. So here is our first program, that is LED blinking program. So for LED blinking we need a two state. One is on state, another one is off state. So here we are going to use the port C. So here I declared port C and tris C status. What are all these? These are the registers. So we going to use whatever the pin we going to use, we should configure. So we going to use the port C. So port C is the register is tris C. So we giving the register value as the tris C and the 07 as port C and status register. This is for selecting the banks. So the RAM memory has 4 banks, no? So we should select the banks for each and every register. For that purpose, this is status register. And another 3 registers are used, that is file register. These registers used to generating the delay. So I'll later explain the delay program. So first we going to select the bank. So what is the purpose of selecting bank? Because we going to use the tris register. Tris register located in bank 1. So initially the PIC microcontroller start with bank 0. So to select the tris register, we are going to switch to bank 1. To switch to bank 1, we need to change the value of 5th bit in status register as 1. For that purpose, we are going to use the instruction as BSF, that is bit set file. So this instruction will set the whatever the pin or whatever the bit given here, it will set to 1. So that is the 2 parameter here. That this is the register and this is the bit we are going to change. And next, changing input or output. So our purpose is output because we are going to use the LED. So we are going to give clear F tris C. So it will give set all the port C 0 to 7, that is all the pin to output port. And next, after configuring the tris register, we should switch to bank 0. That is, we are going to give an instruction as BCF status comma 5. So status register as and status registers 5th bit as 0. So it will switch to bank 0. Our initialization is finished. Now we come to our main program. What is our main program? LED blinking. LED blinking means one is on stage, another one is off stage. For on stage, we are going to use BSF instruction. For off stage, we are going to use BCF instruction. So in BSF, we are going to give the port and the pin we are going to connect the LED. And then next it come to call delay. So our microcontroller works in microseconds. So we cannot view the LED blinking. It resembles like LED on for every time. So for that, we are going to give some delay. That is our eye can visible as seconds. For that we are giving a 1 second delay. Once the LED is on, it should stop for 1 second and it should off and stop for 1 second. Then it will continue the loop. Now we come to delay program. Previously I told that here I am using the 3 registers for delay purpose. So here I am used that registers. That is move LW. So this instruction is used to store the value in W register, that is working register. So here I am storing the value 0x44. And then next I am come to another instruction, that is move WF. This instruction used to whatever the content stored in W register, move to the file register given here. So here I am given a C1. C1 is 20th register of file register. You can verify here also. So it will move the value to C1 register. And next move LW, the same value to the working register, and then move to C2. It's continue for all the 3 register. This label I will explain while explain this program. Okay, next instruction is decrement file skip 0. This instruction is used to decrement the value from the registers. So here I am given the register C3. C3 is 22 registers. The working of this decrement file skip 0 is it will check the C3 register and it will decrement 1 by 1. If whatever the value in the C3 register, it will decrement by 1 and it will check the register it is 0 or not. If it is 0, then it will skip this instruction, or else it will continue this instruction. What is the next instruction? Go to loop 1. This instruction redirect to wherever the label given. So this loop 1 label is given here, that is loop 1 for decrement skip 0. This will run as loop till the C3 becomes 0. Once the C3 becomes 0, it will skip this instruction and jump to next instruction. What is next instruction? Decrement file skip 0 C2. So same process for C2. So C2 will decrement 1 and then it will check. If it is 0, then it will skip this instruction and go here. Or else it will go to loop 2. Where is loop 2? Here I am given loop 2. So loop 2 means again it store the value for C3 and once again you do the 40 times or 44 times to decrement the C2 as 1. So each and every time you want to decrement 1 by C2, you want to decrement the C3 as 40 times. So this is a nested loop. In C program, this type of program is defined as nested loop. At the same way, here also this is called as nested loop. So once the C2 is become 0, then it comes to next instruction, that is decrement file skip. Here also they will given the next file register, that is C1. Once C1 is become 0, then it will skip this instruction and go to return. So return means where the call instruction is called, so to the next it will go here. So the next instruction is BCF. So BCF port C, 0. So this instruction is used to clear the bit of the 0th pin. So port C's 0th pin will get 0, that is LED will off. Then it go to the next instruction, that is call delay. So once again this delay will run. Then it will jump to next instruction, that is go to main. So it will go to here and this process will continue till the power of our microcontroller. It will run as an infinite loop. So this is our LED blinking program. So after writing the program, we should add this file to source file. So add the source, right click and click add. It will add the file and then you should click this build all. It will check whether our program is right or not. So once our program is right, it will show build succeed. After showing this, we can dump our hex file to our microcontroller. Whenever you give build all, it will generate an hex file. To get the hex file with configuration bits, so this is our configuration bit. So to get the configuration bit, you should export the hex file. So click this configuration bit and click OK. It will ask the file name, give blink, then save. It will generate a hex file with configuration bits because we not declare the configuration bits with this file. If you want to enter the configuration bit as here, then you no need to generate this export file. Giving the build option, it will defaultly it will generate a hex file. After building this program, we can check this file through Proteus software by simulating it. After that, we can fuse it to the PIC microcontroller and we can check manually. So I am opening Proteus software. So to get this IC, you can go to components and here you can type the keyword as PIC16F877A. So you will get this IC. Just you can click OK, you can get this. After same way you can get this LED also. So after connecting these wires, you can just double click on it. Go to folder. You should choose the exact folder where you created this program. Here you will find the hex file. Double click on the hex file and you should choose the crystal frequency, that is our crystal oscillator is 4 MHz I am using here. Whatever my megahertz you are trying to use, you can simulate it here. So written here and click OK. Then you can click this play button. So see, here is our program. LED is blinking in a delay of 1 second. So our program is working perfectly, so we can fuse it to our microcontroller.